Hello everybody, I'm Marco Porcaro, the Android tech lead at Synesthesia, and today we're gonna talk about Huawei Mobile Services again, but this time we will see how we can use Huawei Mobile Services and Google Play Services together, and for together I mean in the same application, but of course we will see how to use Huawei Mobile Services to upload our application on the Huawei AppGallery, and of course the Google Play Services for the Google Play Store. So let's start with a quick recap about the Huawei ban. Why is that important? So as you probably know, last year the American government included Huawei in the entity list. What is this list? This is a list of companies, Chinese companies, it's not only Huawei, that can no more cooperate and have commercial relationships with US companies. So one of the things that of course Huawei can no more do is to use Google Play Services inside their phones. So what can Huawei still do? Huawei can use the AOSP version of Android, so the open source version of Android, but Huawei cannot use the Google personalization on top of the open source version. And so one direct consequence about it is that Huawei smartphones cannot include Google Play Services anymore. And what does it mean? What are Google Play Services? Well, let me say normal or standard Android version, or at least the Android version that we know better, we have the operative system and we have our applications, and then there is a component, Google Play Services, that it's like a background service that works as I said, in background, and it's developed by Google, and it offers a lot of feature to developers and to the users, and Google can update this component on its own. This means that it does not depend on the manufacturer to ship a system update, but Google can add other features to Google Play Services, like we saw during the pandemic period, for example, adding the exposure notification API. What's inside the Google Play Services? What are the features provided by Google Play Services? Well, there are really a lot of features, and the most important, or at least the most famous, are Google Maps, and that is contained in Google Play Services, and every application that uses Google Maps has a client component that talks to the bigger ones that it's inside Google Play Services, so that every application that uses Google Maps doesn't have to have a giant library in it, but can use the component provided by the Google Play Services. Another component, for example, is the authentication component used for the Google sign-in, or the push notifications, Google Cast, Google Pay, or Google Fit. There are really a lot of features. Another set of features that are built on top of Play Services are some of the Firebase tools. For example, the push notifications that on Android are the Firebase messaging services depends on Google Play Services. But as I said before, Android exists also without Google Play Services. And in particular, we have Huawei, the new Huawei and Honor devices, but we have also, for example, the Amazon Fire collection of devices. All the devices sold in China doesn't have Google Play Services, and then there is the entire world of custom ROMs that doesn't have Google Play Services. Of course, this list is only partial. And the real question is, should we care about them, the devices that doesn't have Google Play Services? Well, of course, we should care about them because, for example, Huawei has a market share that in the past years has been between 15 and 20% of the entire device sold globally. So it has a really big user base. So for sure we cannot ignore it. And just some other statistics, we have more than 200 million devices sold per year by Huawei, and the Huawei AppGallery has around 500 million users. Just a note on this, the fact that there are so many users that have the Huawei AppGallery doesn't mean that they don't have the Google Play Services, because all the devices sold until the past year have both of them. So there are a lot of devices right now that a lot of Huawei devices right now that have both Google Play Services and Huawei Mobile Services, so both app stores. So just a quick overview about Huawei Mobile Services. You saw a lot about it in the talk of this morning and in the keynote of yesterday. So just a quick snapshot of the Huawei sites. There are really a lot of kits, so a lot of libraries that Huawei developed, and we can say that it's the Huawei alternative to Google Mobile Services. And it's basically the same as Google Play Services for the Google version of Android. So this is a component that runs in background, and it's pre-installed on Huawei and Honor devices. And as I said before, there are dozens of kits. First of all, the map kit, push kit, the identity kit that provides the Huawei login, the health kit, but there are really a lot of libraries. So the first question that we probably need to respond is, should we remove all Google and Firebase libraries to publish on the AppGallery? And the answer is no. We don't need to remove all those libraries for two reasons. The first reason is that we are free to upload our APK on the Huawei AppGallery, and they won't block our upload if it contains some Google or Firebase library. But not all Google and Firebase libraries works, so we need to be careful about it. So what services we can still use? This is a partial list. The full list is on the link below, and we for sure are able to run these services also on devices that doesn't have Google Play services. First of all, Firebase Crashlytics and the Firebase out, but this is a recent thing. It's only starting from the version 20. And we have the Firebase database, Firestore, Firebase Analytics, and the Google Mobile Ads. So all of these libraries will run without any issues. Maybe the Firebase Analytics it's not able to collect all the data that it's able to collect if it runs in on a device that has Google Play services, but the main features are guaranteed. But there are services that we can no longer use. And for example, Firebase messaging, so all the push notifications won't work out of the box if we upload our application on the Huawei AppGallery. And the Google Maps is probably the biggest feature that we don't have on Huawei devices. The Google Mobile Ads Lite, before I've added the Google Mobile Ads because there are two different libraries provided by Google for the advertisement, and one is a light version that needs a part on the Google Play Services component, and the other one is a fully integrated library, so it can run also without Google Play Services. And another big library that we can no more use is the Google Play Services out. That is the library that provides the Google sign-in on our devices. And the last feature that is missing is the Firebase performance monitoring that sometimes is useful to integrate in our applications to know if we can somehow improve their performance. So what can we do? I found at least 3 different options that we will see. And the first option is it's avoid to use both GMS and HMS. This is my least favorite option, of course, but it's an option. So we can search alternatives that works on both, but we need to keep in mind that a lot of them are not free. For example, there are a lot of map libraries that works without Google Play Services or without Huawei Mobile Services, but most of them are paid libraries, so it's not exactly the same. And the second thing that we need to be careful about is that not all features can be easily replaced. For example, the push notifications. Of course, we can try to manage them by ourselves using some background service, but it's not a recommended practice. The operative system can always kill your background service and you won't be able to receive any push notifications. So the most reliable method to have push notifications on Android smartphones with Google Play Services is to use Firebase messaging services, and on devices with HMS is to use Huawei PushKit. And the last thing to notice is that users and customers are used to using some features, for example, Google Maps or Google Places, or in general stuff that they are used to see daily. So it's not so nice for the user to remove them at all. And this brings us to the option number 2. That is my favorite option, and we will see an example of this later. And we can, of course, use the best option on each platform. What does it mean? It means that we can, for example, use Google Maps on smartphones with GMS and Huawei MapKit on smartphones with HMS. So how can we do to do this? We can use an abstraction for the feature, so we need to think about the feature that we want to give to our users, and think how can we abstract these features. And then we need to embed the different libraries on the two platforms, and finally we can have a different implementation for each platform. And the last option that I can think is use both libraries on both platforms, and these can have some pros. One of these pros is that we have a single APK and we can upload it on both stores without care about this one is only for Google, this other is only for Huawei. But it's a bigger APK, of course, since it embeds more libraries than we actually need on each platform. And I think that it's harder to maintain because we need to add a lot of runtime checks to figure out if we have to use the Google library or the Huawei library. And I think that on big projects it's a lot harder to maintain. And speaking about this, these are the two methods that are provided. The first one is provided by the Google Play Services core library, the second one by the HMS core library that we can use at runtime to know if on that device we have Google Play Services or Huawei Mobile Services. And as I said before, we will see an example, or actually two examples. And the first one is how can we refactor an existing map application. I focused on map because I think that it's the bigger feature, that it's different on the two platforms. But of course, this concept can be used in for every libraries that we discussed about. So this is our starting point. We have a basic app with Google Maps, and we have two buttons. The first one adds a random point of interest to our maps, and the second one centers the user to a specific location. And in this map we have the marker clustering enabled. The marker clustering is the feature that collect the point of interest that are one near each other and shows us the number of pins in that specific place. And then we have a single view model that provides all these point of interest. So let me move to Android Studio, and okay. So this is our starting point. We have basically a really simple application with has only one manifest with a single activity. It's a map activity that I've flagged as a launcher activity. So we have our map activity here, And what's inside this activity? It's a super standard activity with the onMapReady callback provided by the Google Maps library. I'm using here the new, not so new, but the new view binding method to use the view and set the listeners on the buttons. So in the onCreate method, I take the binding, I set up the map fragment, and we will receive the onMapReady callback here. And then I simply added the click listeners. We can, in the onCreate method, I load the markers, and the load markers method calls a method in our view model. This is our get marker list that just randomly creates 20 point of interest each time with some random position. So in our activity, we listen for our view model for this list, and we draw them in the marker, and then we call cluster manager .cluster to use the cluster feature. So our starting point is super easy, but also our final point will be easy as well. Let's see how can we refactor this application to have two different implementations for Google and Huawei. So the first thing to do is to add two flavors. I normally use a different file for this. I think that it's more that it's cleaner. So in our build Gradle file, I just apply from a different file that is our flavors.gradle file. In this file, I defined two different flavors, and I've called it Google and Huawei, of course. And if you're not familiar with flavors are like different variants that we can provide for our application. Normally, flavors are used, for example, to have different environments like a development and a production environment. In this case, I've added only these two platforms, and I call this dimension a platform. So we have Google and Huawei. What does it mean? The first thing that it does is to add different variants. So now I have Google debug and release and Huawei debug and release variant for my apps, for my app. So the second thing to do is, of course, is to add all the scripts that we need to add for to implement the Huawei map library. So in the build Gradle file, we need to add the map repository, and we need to add the class path library that is used in the compile time by the library, exactly the same as the GMS Google Services Gradle plugin that analyzed the Google Services JSON in the compile time and prepares all the data for our application. The same things happen for the Huawei AGConnect library with the AGConnect services.json. This JSON file exactly as we normally do for the Google Services JSON that we download from Firebase. This file it's downloadable from the Huawei AppGallery portal. So first thing to do is to set up our application on the Huawei developer portal. I don't show this right now because it's a bit longer process, and we already saw it in the previous talks hosted by Huawei guys. So now that we have our libraries, our Gradle plugins, we are ready to add our dependency. So the dependencies, before if I switch to the previous version, I only had the implementation of the Google Maps, so for the entire application. And in this case, I have the Google implementation, so only in the Google variant I have this Google library, and the Huawei implementation that adds this library only for the Huawei variant. So now that we have our libraries set up, the most important thing is to try to abstract the different features. So in our main folder, the main folder is used by both. So this is the default one, and then the Google and the Huawei one will override these all this stuff. And I've created an abstract class, and I've called it common map activity, which of course it's a fragment activity as before. And here I've tried to abstract some functions that will be overridden by the two different implementations. But I tried to keep here everything was possible, and all that it's in common between the two different implementation. I've added an onMapReady callback by myself that will be called by the two different implementation, and load markers method, and then these 5 abstract methods that we'll see in a few seconds. In the onCreate method, I take the binding, the two different view binding from the two different implementation, and then I set up the map, the buttons, and I call the load markers function. So let's see the changes that I did on the Google version. So we have our map activity, and just a note on this, since in this example I didn't use any dependency injection method, I just gave them the same name within the same package, so that during the compile time one's replace the other, but it's not my favorite approach. I will normally use a dependency injection library like Dagger or Coin to do this. In the Google map activity, I use, of course, all the imports of the Google libraries. So the onMapReady callback is the one provided by the Google library. And the setup button is pretty much the same as before, exactly as the setup map. So in the onMapReady callback, I set up everything I need for the Google part, and I call the onMapReady callback. That is the one that I've added in our abstract class. And the draw markers, it's exactly the same as before, so it adds the the points in the map, and then and it uses the cluster manager to clusterize them. So basically nothing has changed here, but let's see what happens in the Huawei side. On the Huawei side, it's basically the same. We have the same name map activity that extends the same abstract activity. We have here the onMapReady callback that is the one provided by the HMS Maps library. The setup buttons does exactly the same thing, so it centers the map on the Turing position, and it will load the markers. The onMapReady callback it's the same. We will keep a reference for our Huawei map, and then we need to call our super method in our abstract class. And then we have these two different implementations, specific implementation, just to add markers to our map. But the most important thing is that, for example, our view model that contains our business logic is exactly the same. So we don't need to duplicate any code on this part. And our common map activity will get our view model so that both of our implementation will have just the same view model. It's not finished yet because another important thing is that our API key, our map API key that before was, of course, in our Android manifest, now we can move it only in the Android manifest for the Google part, so that the Huawei version doesn't have it. And I think that it's pretty much all for this really super simple example. And I just want to wrap up on this. So let's see the steps that I made here one by one. So the first step is to create two different flavors, the Google and the Huawei one. And the second one is to use a specific implementation for the libraries so that we don't add the unused library on the two platforms. And then we need to create a specific Android manifest in the Google folder that contains the Maps API key. We need to add the Huawei build scripts that generate everything that we need during the runtime part. We need to add the afgconnect file in the Huawei folder, exactly how we do in the Google one. So a note on this is that actually I forgot to do it, but actually I can add this file directly in the Huawei version, and the Google Services one in the Google version. But since these are used during the compile time, are not shipped inside the APK, so it's not an issue to leave both of them in the common folder. So the sixth step is to create two different layouts that I forgot to mention before. In the original version, we had our layout that contains the Google Map fragment and 2 different floating action buttons. And in the new version, I've added the layout, the overlay that it's in common in the main folder here, and then in each flavor I've created, for example, the Google Map activity that includes the Google Map fragment and the overlay view. And in the Huawei res, I've added of course, the Huawei support map fragment and the same overlay view. So in the final result will be exactly the same. So as we saw, we've created a common map activity with a generic view binding. A generic view binding because since we have 2 different layouts, we have 2 different view bindings. So in this case, we cannot use the same reference to the view if we want to use the view binding. We can do it using, for example, the find view by ID method, but I'd like to use the view binding method so that I'm sure that my view exists at runtime. So this is probably the most important part because we need to isolate the abstract methods that will be implemented by the specific activities. This is the real part that we need to do to ship to different application without duplicate a lot of code. So we need to think what is the feature that we have on both the implementation and that are not so related to the specific implementation. For example, the draw markers method, and we can say we need to draw our markers, but we in our common map activity we don't care how this will be actually done in the 2 different implementation. The same, for example, for the center camera method and all the methods that we saw. So this is really the real job that we need to do here. So think about the features and try to abstract them. And the final 2 steps are to create a specific map activity in both in the 2 different folders that extend the common map activity and that will implement all the abstract methods. So this is the final result. It's basically the same application. The one on the left, of course, use the Google Maps library, and the one on the right uses the Huawei MapKit. They're really similar, but you can see that some detail is different, and I think that Huawei with the MapKit did a really great job to add basically the same feature that we are used to have in the Google Map library. Now we have a second example on the push notification. Here I used a different approach for the Synesthesia push manager library. I've added to GitHub like 2 days ago, so I think that it right now has the incredible amount of like 0 stars. And in this library we used a different approach because the Google Maps and the Huawei map libraries, for example, are bigger libraries, so they weight some megabytes, and we don't want to have a giant APK on our stores. But for the push library is not the same, because both the libraries weighs only a few kilobytes, so I think that it's not an issue to have both of them in both the implementation. And we can choose at runtime what's the best option in that moment. So we are free to use the service that we want when both are available. This is an open source library. So of course you are free to add your contribute to this, and we thought that it would be nice to have a libraries that creates an abstraction for the push notification for us. I don't know if I have time to show also this, but I think that I have time, so I can open recent push manager. Let's replace this window. Okay. So just to give a quick overview about this library and how it works. So we have our entry point, that it's our push manager class, and that provides us a push manager instance and two utils that I've added here to know if we have Google Play Services and or Huawei Mobile Services available on our device. So in the init method, we can pass. We need to pass our context, and we can pass our push delegate, our Huawei app ID, our preferred push services, and if we want to print logs or not. So what are these three parameters? So let's start from the simplest one, that it's the preferred push service. This parameter is used when both of the services are available. So for example, in the Huawei devices that were sold, like for example 2 years ago, that have both Huawei Mobile Services and Google Play Services. So here we can define which one to use if we have both of them. The Huawei App ID parameter, it's not mandatory, but it's mandatory only if we want to retrieve the current push token at runtime, only for the Huawei part. And the last parameter is the push delegate, that it's an interface that has 4 methods. These 4 methods notifies us if we have a new token, because as you know, both GMS and HMS can refresh the push notification token in any moment. So we need to have a callback inside our application to know if our token is changed, maybe because we need to communicate it to our backend. So we have this callback, the onNewToken callback, and then we have the onMessage received callback. The push token and the remote message that I've added here are two wrappers for the HMS token and the Firebase token. So here we have the token and the token type, because we probably want to know if the token is a Huawei token or a Firebase token when we receive it. Same thing for the remote message. We want to know if we have received a remote message from Firebase or from Huawei. But in most of the cases we don't care, we just want to receive our remote message. So if you are going to implement these two methods, you will receive a generic push token and a generic remote message, and you don't have to care about which service sent you the notification. But if you need that information, you will receive it here. So let's see what is the remote message. The remote message is a simple data class with all the parameters that are in common between the Firebase messaging remote message and the HMS remote message. So here we have two extension function to map the Huawei push notification to our remote message, let me say, abstraction, and same things happen for the Firebase push notification that we map into our remote message. The other two methods are the on FCM message received and on HMS message received. Note that these are triggered every time that you receive an FCM message. So if you implement both of these, for example, you will receive the callback twice, once for the on message received and once for the on FCM message received. So be careful about this, because maybe if you implement both of these, you will receive the notification callback twice. So basically we have these features, and I've added other two small features. One is like a utility to know which service is actually enabled in this moment, since we saw that sometimes we have both of them available, and we can specify our preferred one. We can need to know which one is enabled in that moment. And other two methods that I've added is the get token method that give us the push token directly. Please note that on some devices, on the Huawei devices with an Emotion UI version lower than 10, this method is not available. So you won't receive any push token here, but you will receive, if you request a token, you will receive it in the on new token callback. And other features that are in this library is the possibility to subscribe and unsubscribe from a topic, and this library will provide the two different implementations for the two different push services. Other methods these two ones, it's only for HMS because the HMS push kit has the possibility to turn off and turn on the push notification. It's something different on Firebase messaging services because we can, for example, delete our FCM token. That it's basically the same as to turn off the push notification on HMS. And okay, I just want to show you the sample on how we can easily use this library. So basically in our application class we need to define our push receiver and initialize it, and we, in the onCreate method of our application, we basically just need to initialize our push manager library, passing all we need to pass. And let me show you my push receiver. It's a super simple class with the two methods that I showed you before. So basically in just like 10 lines of code we are able to use both the push services in our application. Just one thing to note is that until we call this method, the libraries, the push notifications are not available. So I've added in the Android manifest of the library the flag that turns off the automatic initialization of Firebase, because maybe we want to use as a preferred push service the HMS one, so we don't want that our user receive the push notification twice. So the init method will also initialize the real applications, the Firebase one or the HMS one. And I think that's pretty much it. And as I said before, the library is hosted on GitHub, and you can of course read how to implement it on the README page, and feel free to contribute to it and ask questions or add suggestions for missing features. And thank you.